Hi, everybody. Welcome back. We are on Unit 12, Day 2, Friday, April 3rd, 2020. Hope you like my meme. This is how I feel sometimes, even though I don't have a dog. Um, we are on Unit 12. Before you complete this notes video, please make sure you watch the TED Ed on how to speed up a reaction and get a date. The link for that is in the agenda for today's schedule. You will also notice there is a link for a demo called Iodine Clock. If you could watch that as well, I'll refer to it in this video and kind of give you some time to watch it where it goes in your notes. But the link for that is also online. So there's kind of two videos. There's the TED Ed, how to speed up a reaction and get a date, and then there's also a demo video as well. You're going to need your Unit 12 Kinetics and Equilibrium note packet out to page 4. We did page 3 yesterday. When you're done with this notes video, you are going to complete Unit 12 Day 2 skill check on Schoology. There are 6 questions. One is a bonus. It is due the Monday after spring break, which is the 13th by midnight or 11:59 p.m. I hope you all have a relaxing spring break. I know it's been a really tough couple of weeks, and I'm sure you all miss one another. Probably don't miss me very much, but maybe just making fun of me. But I hope you get some relaxation and some recharging over break, so when we get back, you're all ready to go. Okay, so have your notes out, as I said, to page 4. Today we're going to talk about rate of reaction, so the speed at which a reaction occurs. So we're going to look at different factors and how they affect the speed at which a chemical reaction occurs. So when I'm talking about rate, I'm talking about how fast a chemical reaction occurs. And if you watch the TED Ed video, they give some analogies for different factors. We're going to talk about concentration of reactants. We're going to talk about temperature. We'll talk about how surface area affects the rate of a reaction, the nature of the reactants, if they are ionic or molecular compounds, and then what a catalyst does. And I will write the analogies from the TED Ed video under each of the factors so you know what they kind of go with. But what I'd like you to do before you start this is click on this link. That link is going to bring you to this YouTube video. I can't play it through my headphones, so just watch it. It is called the iodine clock reaction, and it's going to demonstrate how concentration affects the rate of a reaction. We used to do this lab in class if you guys were here, and I think it's a cool one. So I wanted you to kind of have that experience of watching it. So pause this video and watch that. So when I refer to it for concentration of reactants, you know what I'm talking about. Okay, now that you've watched the video, we're going to talk about our first factor, which is concentration of reactants. Now, the analogy in the TED Ed video was the size of the hallways. And they say if you make the hallways smaller, it's more likely that students are going to bump or collide into one another. Similar to concentration, you're making it more concentrated. So an explanation for this, if you increase the concentration of your reactants, you're going to increase the rate of the reaction. You're going to cause it to speed up. And if you watch the iodine clock video, the higher the concentration, the quicker that solution turned into that blackish color. So you want to write iodine clock. So the more concentrated, the faster it's going to go. Now, why is that? Remember, whenever we're talking about the speed or the rate of a reaction, we're talking about collisions. The more effective collisions, the faster something's going to go. So if you increase the concentration, you are increasing, I'm going to put an up arrow, the number of effective collisions. And how are you doing that? You're increasing the sites for proper orientation. Remember, you need energy and orientation. But in this case, increasing the concentration of reactants increases the number of effective collisions by increasing sites for proper orientation. Think about the analogy of a smaller hallway. Smaller hallways, more concentrated, meaning you're going to bump into each other more readily. Now, how can you increase the concentration of something? Well, for a gas, we can increase the pressure, which will in turn decrease the volume. and cause the particles to become closer to one another. So say for instance, here's your original volume of a box and here are your gas particles. Let's say we increase the pressure, making the volume smaller. These are going to have more of a chance to collide with one another in a more confined space. It's more concentrated. Now for a solid and a liquid, or a solid in a liquid, to get something to be more concentrated, you can either add more solid solute to make it more concentrated, or you can evaporate off some solvent. That will also make something more concentrated. But overall, you want to remember that if you increase the concentration of your reactants or your solution, you're going to increase the rate at which that reaction occurs. You're going to speed it up. Think about the analogy of smaller hallways. Those are more concentrated spaces, more likely to bump into one another. So that's your first factor. Now if we move down, your second factor is temperature. And the analogy they gave for temperature was cutting the time between classes. Cut time between classes. Now what's that going to do? If you cut the amount of time you have to get to another class, you're going to move a lot faster. And when you move a lot faster, you're more likely to bump into people. So that's the analogy for the temperature factor. If you increase your temperature, you are going to increase or speed up the rate of a reaction. Now, why is that? As I said before, temperature is the measure of the average kinetic energy. So the faster particles are moving, the more likely they are to collide. So why? It's because we're increasing the number of effective collisions. How are we doing that? We're increasing the kinetic energy of the molecules. Here's a real life example of how this works. Refrigerators. I'm horrible at spelling. Let's see if I spell this right. Refrigerator. All right. Refrigerators. They have a low temperature, right? Lowering the temperature decreases the rate of reaction in your food that spoils it. So that's why you keep it in a refrigerator. The lower the temperature, the lower the rate of the reaction, or the slower the reaction will occur. So that's going to keep your food from spoiling, as instead of leaving on the counter where there would be a higher temperature. So increased temperature, increased rate of reaction. And the analogy there was cut time between the classes, you'd move faster. All right, your third one is surface area. And the analogy they gave in the video was to stop traveling in packs. So stop traveling in packs. And that's demonstrating that if you stop traveling in packs, you're going to increase the surface area. There's not going to be people that are surrounding others. So if you increase the surface area, you're going to increase the rate of the reaction. You're going to speed up your reaction. Why? You're going to increase the number of effective collisions. And you're going to do that by increasing the number of sites for proper orientation. So here's an example. Think about a cube of sugar. Here's a sugar cube versus powdered sugar. The cube is going to react slower because it has a low surface area. More of the crystals are contained within the inside. The powder, on the other hand, is going to react faster because it has a high surface area. So powder will react faster. So that's an example of how increasing the surface area increases the rate of reaction. So a powder is going to react faster than a cube. All right. Now, number 4, the nature of the reactants wasn't discussed in an analogy in the video. So I'm just going to talk about this separately. Covalent compounds or organic compounds. So covalent, organic is a more specific example of a covalent compound, typically have more bonds than ionic substances. So think back to our organic unit, those big structures we were drawing, right? Those are going to react a lot slower. So covalent compounds typically have more bonds than ionic substances, so they have a slower reaction. I think I talked about my organic lab in college taking 4 hours because those were covalent compounds. Another thing about the nature of reactants is that aqueous reactions, those that are in solution, in water, remember that means in water, are going to react faster than all others, because when you put something into water, it's going to dissociate or break up, so there is a greater chance for effective collisions. So the type of reactant you have, or the nature of that reactant, whether it's covalent or ionic, or if it's in water, is also going to affect how fast it reacts. And the last factor we're going to talk about is a catalyst. And the analogy from the video for this one was a matchmaker, right? A matchmaker is going to increase the rate at which people get dates because they're going to match them up a lot faster. So a catalyst, if you add a catalyst, it's going to increase the rate of a reaction. Now, in the video from yesterday, the elephant's toothpaste video, they added the catalyst potassium iodide, and that is what caused all of the hydrogen peroxide to release the oxygen bubbles that lead to that huge kind of fluffy burst. That is a catalyst that they added in order to cause that reaction to occur quicker. Now, why does a catalyst work? Well, as always, anytime something's going faster, we're increasing those effective collisions. But a catalyst does something a little different, and we're going to talk about this word activation energy tomorrow. But a catalyst provides a different reaction pathway and lowers something called the activation energy. As I said, we'll talk about that tomorrow. But a catalyst basically makes a mountain and turns it into a hill. It creates a different pathway that's a little bit easier to get over. So that's what a catalyst kind of does to speed up a reaction. So notice for all of these factors, we're discussing how we can have more effective collisions to speed up a reaction. So in summary, what you want to remember, if you increase the concentration of a reactant, you're going to increase the rate of that reaction. It's going to go faster. And the iodine clock was the video that kind of demonstrated that. For temperature, if you increase the temperature, those particles are going to speed up. They're going to collide more frequently. So that's also going to speed up or increase the rate of a reaction. The surface area, if you increase the surface area, so say you make something that's a cube into a powder, you're now going to speed up or increase the rate of the reaction because there are more places to collide. Covalent substances usually react more slowly than ionic because they are larger. And then if you are in solution, that's going to be fast as well. And then the last is a catalyst. If you add a catalyst, you're going to speed up reaction because it lowers this thing called the activation energy, which we will talk about tomorrow. Notice I wrote all of the analogies under here to kind of help you. Please make sure that you do the skill check for today. There are, as I said, 6 questions. One's a bonus. Please be sure to write under the discussion for today if you have any other issues. Adios, everybody. Have a good weekend and a good spring break.